Okay, guys, good morning. We'll go ahead and get started. Before we do, hopefully you saw I put up exam 2 and exam 3 and homework 7. Homework 7 is our final homework. So if you haven't had a chance to look at those documents, make sure you take a look at them. Exam 2 is just kind of a spin-off off the garage door program you did I think you did during lab 4. One of your labs was a garage door program. So all you gotta do is make just kind of a little adjustment to that program. Make sure you read the instructions and submit it exactly like it says in the instructions. So that shouldn't be that big of a deal for exam 2. Exam 3, we had met face to face. We would have spoke about something called human-machine interaction or human-machine interfacing. Just a PowerPoint, so I figure I'll make that into an exam. Basically, you look at the PowerPoint, there's a link or two that you go to, and you answer some questions. So that should be a really nice boost to your GPA if you do that, get it submitted on time. Again, look at the due dates and make sure you read the instructions and submit both of those exactly as it says in the instructions. The homework 7 is it's a reaction paper. You'll look at a few videos, write a reaction paper, and then that'll be it. There's only 7 homework assignments for the whole semester. And the only thing we have to worry about, and the only thing that's kind of got to be figured out now is the final. There is a standard final I give to this class every time I teach it, but I won't be able to do that this time. So I have to put together another final exam. We'll finish the lecture material early, but the final exam, I'm probably going to give it on the week of the finals, but we'll talk more about that as we get a little bit closer. So take a look at exam 3, exam 2, get started on those early, get them out the way, put them up on Blackboard. I can start looking at them, and be less for you to have to worry about as I'm sure you have other exams and other assignments and other courses. Today, what I want to do, though, is we've talked about 3 tools for solving logic or Boolean problems. So the idea is that you go into a place, you probably won't be the one to install the PLC. The PLC is already installed by some kind of a technical person, technician, and you might be asked to write a program. And so the idea is not only to get the program to work, but to write the most efficient program that you can write. And so the tools that we've looked at so far, we looked at the standard SOP, which is just a way to express the logic. So the idea is that you're probably talking to a non-technical person, probably not an engineer. You'll go in and you'll see how this factory is supposed to work. They need to give that to you in prose. They'll write it down. You will write it down, write down how the system is supposed to work, and then you would translate the prose, you would translate the English to and or logic. And the idea is that you can represent terms as variables and that you can write them in the form of a standard SOP. Those are the steps you got to be able to get to. So the SOP is just a kind of a structure, a standard way to write it that will make the logic fit into both a truth table and the K-map. A truth table is just it's an organized way of laying out all the possible combinations of the inputs and determining for a certain combination of inputs where you want the output to be true. So that's a tool that we can use. The K-map is a way to, once you have either a standard SOP, the logic in the form of a standard SOP, or a truth table, the K-map is a way, if you have a complex expression, you can reduce it down to the guaranteed minimal expression. So what I want to do today, if you haven't had a chance to go to Blackboard and download the document for today, I'll pause for a second. Go ahead and either print it out if you have print capabilities, or at least bring it up on your screen and take a look at it. It's a really simple problem that you really don't need any of this to solve the problem. You can just think about it and probably write the program right away. But it's not my purpose today to give you a difficult problem. What I want to do is take you through the logic or the steps that you would use a truth table to solve a problem. And then later on, we'll look at the way you can use the truth table together with the K-map to solve a practical problem. So this problem is pretty simple. If you haven't had a chance to go to Blackboard, go there now. Download the document for today. It's in the week 12 folder and it's dated for today. Print it out if you can. If you can't print, just take a look at it. I do have it here, so I'll read it and I'll put it up on the board. And I just want you to, we'll work through it together. So I'll pause for a second, go to Blackboard, get the document if you don't already have it, and we'll take it from there. I only have this session set up to go to, this will be short, so I think 9:35, so we'll get through this kind of quickly. This is a short lecture. And as I said, with the way things are now, we have more time than material, so we're going to finish this early, and you guys will have some time to just kind of work on those other projects that I have for you, the exams and the homework. So you'll need the document for today, and if you have that, if you don't have that, get a pen and pencil, or paper and pencil, and I will read the problem statement to you. And again, when I read it, it's really, really simple. You can solve it probably right away without going through any of the steps. But I want you to go through the steps, because what I'll do later on is give you one more complicated problem that you can't just read and solve. So here, I'll read the problem while you guys are gathering your notes and your pen, paper, and whatever. So this is controlling a device from 2 locations. It says design and test a PLC program which allows a light to be controlled from 2 locations. If both switches are on or off, the lamp should be on. For any other possible switch combination, the lamp should be off. And they give you a list of addresses. It says use the following addresses in your simulator to test the program to see if it really works. And they give you addresses here. Switch 1 is input card 1, bit position 00. If you think about the input-output image table. Switch 2, second switch is input card 1, bit position 01, and then the output address would be output card 2, bit position 00. So this is a classic problem. You probably have this, or you may have this in your house if you've really seen it. It might be a situation where, let's say you have a switch at the bottom of the basement and you have one at the top of the steps, and you want to be able to control a light, maybe the light in the basement. You want to be able to control that from both switch positions. But the logic says that when both switches are on, you want the light bulb to be on. If both switches are in the off position, you want the light to be off. If any other condition, you want, no, I said that wrong. If both switches are on or off, you want the lamp to on. For any other combination of inputs, you want the lamp to be off. So again, you can write it down directly, but let's go through the steps here as defined in the document. So the first thing they want you to do is to list the inputs and outputs along with their addresses. So if you have pen and paper, go ahead and do that. You want to make a column inputs, you want to make a column outputs, and you want to label each one either with A, B, if you want to use variables, or you can use switch 1, switch 2, whatever. But make your list, and this is actually taking you through what I expect to see on the final exam. This is an exercise to get you kind of geared up for that. So what I'm doing here is what I'm going to expect to see on the final exam. So go ahead and if you have the problem statement, I'll read it one more time, but make your list. It says design and test a program will allow a light to be controlled from 2 locations. If both switches are on or both switches are off, the lamp should be on. For any other switch position, the lamp should be off. And then they give you these addresses. So the first thing it says is make a list of the inputs and outputs along with their addresses. So you go ahead and do it on your paper. I'll do it on the board. Okay, so here's my list of inputs and outputs and the addresses. Now this is a really, really simple problem. As you can imagine, if you had something, you know, if you were actually doing this for some kind of industrial process, you may have 10, 15 switches. You may have more than one output. So you can see why you want to have this way to keep track of things. You might want to use an A or B here. I just use switch 1 and switch 2. And you could use A, B, and X. That's what we've been doing in the class. And it may be a little bit better to think about that way. But I'll leave it as is here. So that's step 1. So yours should look something like this. Excuse me. Step 2, it says design the truth table to represent the logic. Design the truth table to represent the logic. The logic is when both switches are on or both switches are off, we want to have an output to the lamp. We want the lamp to be on. So how would you represent that in the truth table? And there's a little side note on the paper that says, how many rows do you need for the truth table? So let's answer that. Well, remember the number of rows in the truth table is just 2 to the nth power, where that n right there is a number of variables. The number of input variables. We got 2 input variables, so we got 2 to the 2, we need 4 rows. So what you want to do now is correctly number a 4-row truth table, and then you want to put in where you want the conditions to be true. And then from that, we'll get the Boolean expression, and then we'll implement it, and then that's it. That's all there are to it. That's all there are to it. So go ahead and put together your truth table. And again, it's important to get the correct sequence of numbers. Basically, all you're going to do is count in binary. And if you do what I said before in other videos, that these first bits, you just alternate every other bit. And then the next column, every other 2 bits. And then it goes by powers of 4. So every bit, every 2 bit, every 4 bit. If I had another set of variables, every 8, 16, 32. I'll never give you one that big though. That's crazy. You'd be here all day. So here's the truth table. So what will be my next step? What's the most logical step? What do I want to do next?
Figure out which ones would be on and which ones would be off.
Say that again. Let me turn my audio up. Somebody answer. Speak again.
Figure out which combination would actually turn the lamp on and which would not.
Exactly right. Which combination is going to turn the lamp on and turn the lamp off? Well, they say we want the lamp to be on when both switches are off, so that means I have a 1 here. And when both switches are on, I want an output that's true. I want the lamp to be on, so I have a 1 here. And for the other positions, there's zeros. I'm going to leave the zeros out just to keep it clean. So that's it. That's my truth table. Now, if I had a bigger truth table, we'll get an expression from this. Then you could use a K-map to minimize the expression that you will get, so you have a way smaller expression. But for this one, we don't need the K-map. This is good enough. So what I do now is write my expressions from the truth table. So remember, anywhere I see a 1 is a SOP. Zeros are POSs. We only deal with SOPs. So I got a 1 here, so that means I got switch 2 by switch 1. And since these are both zeros, they're not. If you're using A's and B, this would be A, B, not. And then right here, I got the same thing. I got switch 2 by switch 1. These are 1, so I don't knot them. So if you're using ABs, this would just be AB. And all we need to do to get a solution is OR them together. So the lamp would equal SW2, SW1, bar, and these are ANDed, or I have to get rid of my truth table. SW2 dot SW1, and those are unbarred. And then the final step of this problem, they want you to implement this. You could go from Gates to the program if you wanted to, but they say go directly to the program. So go ahead and write out the program for this. This is really, really simple. So I got these two ANDed. This is SW2, SW1, and these are both knotted. And then I got the same thing, but they're not knotted. And then this is my lamp. And we're happy. That's it. So that is a really, really, really simple problem. But again, the point is you can see the steps that you would go through to get the actual working logic that you would put into the PLC program. Now, there is one more step. They actually want you to implement this in the PLC to make sure it works. You can see it's gonna work, but just for giggles, go ahead and implement that, put that in your simulation software and show me that it works in bit positions, and I'll have a place you can upload it. I know I said that homework 7 will be the last homework, but this is stupid easy. You might as well get 100 points for it. So just put this in the simulator. You can, I don't know if I want you to upload or just take a picture of it. Just upload it to Blackboard and I'll give you 100 points. Some of you need it, so that'll be a free 100 points on this. I think that's it. That's all. This is pretty simple, this problem anyway. We'll get to some more interesting stuff this week and get you ready for the final exam. Anybody have any questions or comments? Did I forget to press record? I think I pressed record. Okay. Anybody have any questions, comments, or concerns?
Well, this might be the smartest question, but what's RLL stand for?
Relay ladder logic. That's the stuff you've been putting in the simulation software. Yeah, that's just the language they use. So represent it. You can represent it using Gates, but it's a PLC course, so you go from Gates to the logic. So RLL's relay ladder logic, just this stuff.
Got it. Thank you.
So put that in your simulator. Prove to yourself that when these are both, that the logic works. You know, when these are both true, or this condition is true, then the lamp lights up. For any other condition, it doesn't light. Snap a picture of it or whatever you do. Put it up on Blackboard. You got 100 points.
So is this going to be homework 7?
This is homework 8. Homework 8. It's a good question. Okay. Homework 7 is on Blackboard. Make sure you look at that. So this title this homework 8, and this will be the last homework, I promise. But this is just really easy. But homework 7 is, I think you'll like it. Homework, you got to watch a couple of YouTube videos and just write a reaction paper to it, some stuff. So there's 3 videos I want you to watch, and then you can put it all together in one paper, and I'll just read. I'll read the one paper. It's not a big deal. It's just like 2 pages or something like that. So it'll be all right. Just don't wait till the last minute to do it. Get it out the way. Get the garage door program should be fresh in your mind. You probably still got that in your computer. Go ahead and tweak that and make it work the way I asked in the instructions. Get that out the way and get it loaded to Blackboard. Even though I think it's due the end of next week or something, just get it out the way. Get it done. Get it out the way. Get your grade for it. And then homework in exam 3, which is the video reaction paper, that's easy to do. Get that out the way. And then all you have to do is worry about the final exam. So if you get that done early, you'll be in really, really good shape. And then we'll probably be done with the course early, and you'll have the rest of the time to focus on your other classes. So don't wait to the last minute is the name of the game. Anybody have any questions, comments, concerns? I'm still working on grades. I promise this week I'll get a lot of grades up there. You can kind of see where you stand, but there's no reason why you shouldn't get 100 on the program. Program is really, really easy to do. If you've been here at all and you've been kind of following what we're doing, that exam too will be a piece of cake. I just want to see if you can do a basic program. You're not even doing a program, you're making an adjustment to a program you've already done. And then the reaction paper is nothing. So the only thing that you may have to worry about a little bit is the final exam, but it'll be okay. So this working remotely thing has kind of limited my ability to apply stress to you guys like I normally would in a face-to-face situation. But I think it's fun, and I think you'll learn something from it. So it should be all right. Any questions or comments?
What happened to that one dog you found on the street?
Oh, let me show it to you. Hold on a second. Let me go get her.
Yeah, I'm so excited.
What did you do? No hat today, Elijah?
I just took it off.
Did you guys all get that project done for Wooden?
Still haven't started.
Oof.
No, I'm actually really,
Right
really
now.
to having all parts ready, I think. I spent all night last night researching, trying to find all of Wooden's things, videos and papers.
Yeah, it's like all in some of the lectures. So.
All right. So can you guys see her?
Oh.
Oh my gosh.
She's so tiny.
This is a long-haired Chihuahua, according to the vet. She's tiny. She doesn't want to look in the camera. She's chipped. She does have a chip in her, so I took her to the vet, and she doesn't want to look in the camera. She must know she's on camera.
Yeah.
And she's shaking. But I took her to the vet. She has a chip, but the numbers, it's 2 numbers. They're not any good. The address, I went to the guy's house and they cussed me out, so I figured they weren't the owners. I got an ad on Craigslist. I actually been getting calls from people saying that if I don't find a placement for her, that they would take her. So right now, we still have her, as you can see, and my nephew has named her Bella, so I don't know if that's good or bad. We may end up with another dog.
Now, what's your
yeah.
name there?
Yeah, I know, right?
So, wait, how did that house interaction go? I want to hear this story.
Which one?
Where they cussed you out.
Oh, I just, so the address is actually close to where I live, so I really, really was hopeful that it was the owner. So I went there and I knocked on the door, and a really mean looking, this guy was maybe in his 30s. It was early, so I mean, I get up at like 5, so 9 o'clock is not early to me, but this guy was maybe in his mid-30s, and he just wasn't very happy when I knocked on the door. He didn't come to the door right away, and I knocked and I knocked and I re-knocked. And eventually he came to the door. He just mean-mugged me, and I asked for the name. I won't mention the name, but the name of it was 2 owner names attached to the dog, and they basically, he told me in no uncertain terms that they didn't live there anymore, which made me feel like he might have known who they were, because he said they don't live here anymore. But the way he came at me and his demeanor and all that, he wasn't very pleasant at all. So I just put my tail between my legs and got in the car and drove away. And I said I'll try to find him another way. I did go back to the vet about a week ago, and I got the last name of the owner. So I'm going to try to do a Google search, and if that doesn't work, we'll either end up keeping her, or I know a couple people that want to adopt a little dog.
You got Facebook?
I do not, but my nephew has Facebook. He has an ad on Facebook. There's some kind of thing he put her ad in. I wouldn't let her put the picture up because I figured people might claim her that didn't really own her.
You can
But
search
it
the
is,
people on Facebook.
say it again.
You can look up the people on Facebook.
That's another idea. I didn't think about that. Thank you. So this it's funny because I have a cat and pit bulls, and they all get along just fine. So thank you for asking about her. I forgot I wanted to show you guys, but this is her.
Really
Okay, guys,
cool.
you guys have a great day. Stay safe, and I will see you. We'll do another problem on Wednesday, and then probably Friday. Friday we'll finish up. If not Friday, we'll definitely be done by Monday, and then the next thing will be the final exam. Okay.
Thank you,
Alrighty.
Professor.
All right, guys. See you later. Stay
See you
safe.
later.
Please.